Ingenuity is a fully autonomous helicopter that makes its own decisions. Why did it decide to abort its most recent flight?
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars.
On Sol 43 of the mission, April 4th on Earth, Ingenuity was deployed from Perseverance for what was expected to be a month of test flights, maybe 5 total, to see if a helicopter could actually fly and operate in the barely there Martian atmosphere, which is about 1% of Earth's atmospheric pressure. After 6 months and 13 flights, Ingenuity has outlasted the season it was designed to fly in. It's now Martian summer in the northern hemisphere, which means the thin atmosphere is getting thinner as CO2 migrates to the South Pole, forming a dry ice cap in the frigid winter there. That will make the air in Jezero Crater about 20% thinner. So Ingenuity will have to spin its blades even faster to generate enough lift, from about 2,500 RPMs to 2,700. The planned test at 2,800 RPM on the ground showed that the blades spinning at 80% of the speed of sound didn't produce too much drag or any bad vibrations. The next test was on Sol 206, September 18th on Earth. Ingenuity would spin up its blades to 2,700 RPM and fly up to 5 meters, or about 16 feet, and hover briefly. But Ingenuity decided not to take off. Turns out that it detected an anomaly during its pre-flight check. It tests the 6 servo motors that control the blade angle or pitch using what the team calls a servo wiggle. 2 of the 6 servos oscillated about 1 degree from their commanded position. The team suspects that wear in the moving parts after more than twice the planned number of flights, or maybe something about the high-speed spin test, may have caused the anomaly. 2 additional servo wiggle tests on Sols 209 and 211 showed no anomaly. The team will have about 2 weeks during solar conjunction to complete the analysis. When the sun comes between Mars and Earth, radio communications are unreliable, so better to not risk creating problems during this period. This final view from Ingenuity's color camera sent just before solar conjunction shows the evening sun lighting up the ground under and around the current landing site. There's a coarse sand lag deposit on a ripple out in front and the dusty foot of Ingenuity to the side. The dust got stuck on this foot when Ingenuity landed on a similar ripple on its 12th flight. Here's the view of the foot fresh out of the box. The weave of the carbon fiber is clearly visible, and here's how it looked just before landing on Flight 12, maybe just a thin film of dust. Here's the first shot from the nav cam after takeoff on Flight 13. The footprints are visible where dust has been disturbed from the darker sand below. Some of that dust is now stuck to Ingenuity's feet. Here's the first shot from the color camera after takeoff. Lots of reddish dust stuck on. Here's the last shot before landing, a minute and a half later, same dust. I wanted to show this as a demonstration of how sticky Martian dust is, probably because of the electrostatic cling in the hyper-arid environment. This also shows that even the prop wash of helicopter blades spinning less than 2 feet overhead is not enough to clean off the dust. So this is not a solution for cleaning off solar panels on Martian spacecraft.